Welcome my dear students to the part 1 of today's session. In this module, let us discuss about coupled forces and principle of moments. A couple is a pair of forces acting on a body that are of equal magnitude and opposite direction, acting parallel to one another but not along the same line. The torque of a couple is the rotation force or the moment produced. So you can see from the figure the example for a coupled force which is equal in magnitude but opposite in direction. In the previous session, we had discussed that for an object to be in rotational equilibrium, F net is not equivalent to 0 but tau net is equivalent to 0. And for an object in translational equilibrium, F net is equivalent to 0 but tau net not equivalent to 0. So the second case for translational equilibrium will help the object to rotate. These are examples of coupled forces which help in rotation of objects. The first one is opening the lid of a bottle. Second example is opening a tap. Third example is using a screwdriver. You are fixing a screw by rotating it. And next is drying a wet cloth. In all these cases, you are applying coupled forces. Now, let us discuss about the principle of moments. All of you might have enjoyed playing in a seesaw. So we can see if one of the weights is higher on any one part of the seesaw, the object will tend to move in that direction. That is, if the anti-clockwise moment and clockwise moment are equal, then the seesaw is balanced. This is known as principle of moments. When something is balanced about a pivot means the center point, total clockwise moment is equivalent to total anti-clockwise moment according to the principle of moments. If the seesaw balances, the turning effect anti-clockwise must equal the turning effect clockwise. Or else this is an example of principle of moments. Anti-clockwise moment is equivalent to clockwise moment. Now from this example, let us describe the parts of a lever. The center point where the lever is fixed is known as the fulcrum. The point at which the weight to be lifted is placed or the load is placed is known as the load arm, and the distance from the fulcrum where the effort is made in order to lift the load is known as the effort arm. Now in order to lift this heavy load about the pivot, effort is made in the opposite direction by a person. So this is an example of lever. Now let us see the principle of a lever. Let D1 be the distance of the applied force from the fulcrum or the pivot point, and let F2 be the object lifted, and it is at a distance of D2 from the fulcrum. Then, according to the principle of moments, input moment must be equivalent to output moment. Moment means force into distance. So, input moment is F1 into D1 and output moment is F2 into D2. So, according to the principle of levers, F1 D1 is equivalent to F2 D2, or else F2 is equivalent to F1 into D1 by D2. Since D1 is very much greater than D2, we need to apply only a small force in order to lift a heavy load. The mechanical advantage of a lever is given by F1 by F2, which is equivalent to D2 by D1, where F1 is the load and F2 is the effort. D1 is the load arm and D2 is the effort arm. Hope you might have got an idea about the principle of levers, that is a principle of moments and coupled forces. Thank you, dear students.